students, today we are going to start our first chapter of class 9th chemistry, that is matter in our surroundings. Okay. Before starting any chapter, okay, हमेशा whenever you are learning a subject, whether it is physics, chemistry, biology, mathematics, any subject, ठीक है, सबसे पहले फोकस क्या होना चाहिए, हमारे सब्जेक्ट हमारे चैप्टर का नेम क्या है, बिकॉज दिस इज़ द फर्स्ट एंड वेरी बेसिक चैप्टर ऑफ केमिस्ट्री. उसके इसलिए आपको सबसे पहले स्टार्ट क्या करना है, नाम क्या है चैप्टर का उससे स्टार्ट करना है, राइट. यू विल बी आस्किंग क्वेश्चंस टू योर सेल्फ, what is this, what does the name of the chapter signifies, है ना, what are the different terms that are present in names and what are the meanings of it, है ना. फिर धीमे धीमे we will be diving deep into the name and diving deep into the reasons and all the classification, everything of matter that is present in our surroundings. Okay, so the very basic question that will be coming in your mind while just reading this chapter's name is, ma'am, we know very well about our surroundings, okay, but we don't know what is matter. Is matter something abstract noun or it is the material noun? Don't worry, we are not learning English, but the thing is you might be thinking like that, okay, कि we can sense it or not, what is it actually, right. Matter is something that is present in everything, like you can say everything that is present around us is called as matter. Doesn't mean what is its properties, it doesn't matter, okay, it doesn't matter what are the properties of matter. We will be learning all the classifications, we will be learning all the characteristics, right. We will be learning about different nature of matter, right. We will be learning types of matter, we will be learning why there are different types, okay. What are the things, what are the chemical properties or physical quantities that apply, that have some effect on matter, okay. So all these things we will be learning in this chapter, ठीक है. See, this is the introduction of the chapter. Let's move to the next slide. See, this is the very basic definition. If someone will be asking you what is matter, you will say anything around us that is having space, that occupies space, that have some mass, that have some volume, okay, and can be sensed. Fine. So there are 4 points that you have to remember. First is matter occupies space, right. Second, it has mass, correct. Third, it possesses volume, of course, okay, and last thing, it can be sensed. Sensed by our sensory organs. Sensory organs means our sensory organs include nose, eyes, ears, like that, okay. So if there is a matter present, okay, it will be occupying space, it will be having mass, it will be having volume, and it can be sensed. We can touch it, we can see it, sometimes we can smell it also, okay. So all these examples we will see in our upcoming slides, don't worry. So this is basically the introduction of the definition, or you can say the basic definition of matter. Let's move further. If I want to give you some examples of matter, just anything, like the pen I am holding right now, okay, the chair in which you are sitting right now, suppose you are drinking milk or tea or coffee, that is also called as matter, okay. A cup of coffee, it is actually mixture of 2 types of matters. One, the cup is made up of solids, and the coffee in it is made up of is actually a liquid, okay. So that are the definitions, or you can say definition and examples including together for matter, okay. Let us move further. Fine. So we are defining matter, but we also have to know what are the different types of matter, or you can say what how matter will be divided broadly. Okay. So if suppose we have for example we have candies. Okay. So we can divide candies according to their flavors in two broad types. There are sour candies and there are sweet candies, right? Similarly, matter also can be divided into two broad classifications, that are physical classification and chemical classification. Okay. Any quantity if it is regarded as physical quantity, it will be related to the size or shape or something that is related to its appearance. Okay. So physical classification of matter will be including size of matter or shape of matter or color of matter or any appearance, you can say how it will look like, how the surface of matter will look like that. What about chemical classification? So always remember, if you are learning chemistry, there will be chemical compounds. For example, CO2 is a chemical compound. CO2 is a gas, carbon dioxide. Okay. So it is made up of two elements, carbon and oxygen. I am writing CO2, it is made up of carbon and oxygen in ratio 1:2. Okay. So by this ratio of number of elements that are present in a molecule of carbon dioxide, it shows that there are different number of atoms or number of elements can be present in different chemical compounds. This is what we called as chemical composition of a chemical compound. Okay. So chemical classification of matter can be done like this. There are a lot of compounds like iron sulfate, or you can say ferrous sulfate, aluminium nitrate, right, calcium carbonate, water, carbon dioxide, nitrogen molecule. They all have different kinds of atoms. So that is actually according to chemical classification, right. So we have broadly divided matter into physical classification and chemical classification. Let us move further. Okay. So in physical nature of matter, basically, if like I told you, in physical quantities or physical nature, we actually care about appearance. We actually care about how it looks like from the surface, or yeah, you can say that. So physical nature of matter is also divided into two types. Okay. First is continuous nature, second is particulate nature. Okay. But how can we say, actually you might have known what is the meaning of continuous, okay, what is the meaning of particulate. If not, I will be telling you, do not worry. But see, how can we say that a matter is continuous or particulate? We will see in examples, right. So let us dive into it. See, continuous nature of matter क्या कहता है कि अगर हमारे पास कोई भी चीज़ है, लाइक आई सेड मैटर कैन बी एनीथिंग, कोई भी थिंग है, अगर कंटिन्यूसली देखने पर इट इज़ नॉट डिवाइडेड इनटू पर्टिकुलर अदर थिंग्स, है ना, वो कंटिन्यूसली सेम ही दिख रही है. फॉर एग्जांपल, इफ आई विल सी अ ग्लास ऑफ वाटर, और आई कैन से वाटर कमिंग आउट ऑफ अ टैप वाटर, है ना, तो इट विल लुक लाइक कंटिन्यूसली. ऐसा नहीं है कि वाटर ऐसे थोड़ा सा आया फिर वापस फिर आ रहा है, इट्स नॉट लाइक दैट, है ना, इट विल बी कमिंग कंटिन्यूसली. सो दैट विल बी कॉल्ड एज कंटिन्यूस नेचर ऑफ मैटर. Examples can be liquids or gases. Fine. But what do you mean by particulate nature of matter? See, particulate means particle nature. Okay. Particulate means particle. So in particulate nature, we actually see matter as having different particles, for example in solids. ठीक है, तो for example you have 10 grams of sugar, you will see there are different cubes of sugar. It is particle in nature, है ना, it is not continuous, it will be discontinuous. So that will be called as particulate nature. We can write as cubes of sugar or salt. Like that you can give me a lot of examples, like crystals of diamond crystals, right? Crystals of if not crystals, we can say powder also. So powder of CuSO4, copper sulfate is a kind of powder. It's also particle in nature. Powder, it's not continuous, it will be divided into different particles. Okay, so that is about physical nature of matter. I hope you are able to understand. Let's move further to the next slide. Okay. Now, like I said that there will be particulate nature of matter and there will be continuous nature of matter. Whatever matter it is, whether it is a continuous or particulate, doesn't matter. ठीक है? Okay, it doesn't matter what is the nature of the matter. Basic thing is all the matter will be made up of particles. That is the very basic statement that have been given. ठीक है? क्यों? How? So always remember there is a concept map of making up of matter. ठीक है? हम हमेशा कहते हैं like matter, if something anything that is present around us, it is having some basic building blocks, right? जैसे कि हमने बहुत बड़ी बिल्डिंग बनाई, the building block will be bricks, है ना, bricks से वो बिल्डिंग बनती है. वैसे ही कोई भी मैटर किससे बनता है? एटम से. Chemistry, if you are learning chemistry, you will be definitely learning about atoms because everything is made up of atoms only. ठीक है? So you know atoms, they will be making matter, not like just कि atoms आए मिले और just like matter बना लिया, ऐसा नहीं है. कुछ और भी concept चीज़ें होती हैं, जैसे atoms जो बनते हैं वो किससे बनते हैं? Electrons, protons and neutrons से. Why? There is no why obviously because it is they are called as subatomic particles of atoms. There are also some other subatomic particles of atoms, but you are not supposed to go through them right now because you are in just class 9th. You will be learning much more in upcoming higher classes. ठीक है? Electron, protons and neutrons will be making atoms. Atoms will be making elements. One type of atoms will make elements. Okay? Elements, different type of elements will make molecules. And different type of molecule, no, sorry, not different type of molecules, same type of molecules make compounds. And different or same type of compounds will make matter. Okay, so you can say whether a compound is a particle or molecule is a particle. You can say element is also a particle. Any building blocks of a matter will be called as particles. ठीक है? But one thing is clear. What is that? Matter will be made up of particles, है ना? But how do we prove it? What are the evidences of particles of matter? ऐसे कैसे prove कर सकते हैं? That we will be learning in from the next slide. First evidence is, this is the first one. Dissolving a solid in a liquid. Now let's take any solid, salt powder or sugar powder. कोई भी liquid लेते हैं, एक beaker लेते हैं. The very best liquid that we are having is water. Okay, we will try to dissolve sugar cubes in water. ठीक है? क्या होगा? We will be learning an activity also based on this कि हम लोग dissolve करेंगे solid को sugar में. But that activity will be telling us about characteristics of matter. Right now we are learning about evidences to prove that particles are present in matter, correct? So you will see that sugar cubes were completely just disappear. It looks like the whole only water is present in the beaker, okay? And even you will see that level, suppose the level of water initially was 100 ml, because आपने देखा होगा in chemical laboratories beakers होते हैं, test tubes होते हैं and measuring flask होते हैं, उसमें mention किया होता है volume 100 ml, 50 ml like that. So beaker में भी suppose हमने 100 ml का beaker लिया and we have marked H2O level up to 100, ठीक है? जब हमने शुगर को डिसॉल्व किया, वी हैव नॉट टेकन अ लॉट ऑफ शुगर, वी हैव टेकन जस्ट सफिशिएंट अमाउंट ऑफ शुगर and it just disappears and even the level of the water does not increase. That means there are some particles present in matter that are taking sugar particles between them, correct? For example, I am taking circles as H2O molecules, ठीक है, and I have taken stars as sugar cubes, or you can say sugar molecules, because sugar is also a chemical compound. We can write it as sugar molecules. So I am again making it. In the beaker I have H2O molecules, and H2O molecules will be present like this, ठीक है? Basically it will be having some spaces between them. The molecules will be having some spaces between them. When we will be adding sugar molecules, they will be going between these spaces and they will be completely dissolved, okay? So because of dissolution of sugar completely in water, we can say that particles are present in matter, right? Dissolving a sugar solid in a liquid is one evidence of presence of particles in matter. Let's move further. Let's see the second evidence. Mixing of two gases. Okay, this will be our second evidence, okay? Mixing of two gases. See, you might have seen that or you know very well that air is basically mixture of different gases. If I write the composition of air, you know that it is made up of nitrogen gas, oxygen gas, carbon dioxide, right? Some dirt particles, or you can say dust particles, sometimes noble gases also like argon gas, etc. Okay. So mixing of two gases can happen very quickly. If suppose in a chamber you have oxygen gas and you have hydrogen gas, okay, if you will be supplying a lot of air, a lot of temperature, what will happen? Hydrogen and oxygen will combine together to form H2O. Yes, I am not saying that this is a very easy reaction, but still it will be happening if we will be supplying perfect conditions, okay. So H2 and O2 can mix with each other. Can mix together simply. This is also an evidence of matter. Let's move further. Let's see the next evidence. Okay, so that's a very interesting evidence, that is movement of pollen grains in water. There was a scientist named as Robert Brown. He invented Brownian motion. What he observed? He observed the things that we observe daily. Simply, if suppose we have, I just don't want you to pour some dust particles in your tea or coffee, but I am just telling you, for example, if I have some small dust particles and I will be putting them in my tea or coffee. I don't want it, but let's suppose. ठीक है, तो क्या होगा कि वो डस्ट पार्टिकल्स हमें मूव करते हुए दिखेंगे. दे विल मूव हेयर एंड देयर लाइक दैट. वैसे ही अगर हमें चांस मिला होता तो वी वुड हैव इन्वेंटेड इट, इजंट इट. बट ब्राउनियन मूवमेंट को इन्वेंट करने का चांस मिला रॉबर्ट ब्राउन को. ही एक्चुअली ऑब्जर्व्ड, ठीक है, कि पॉलन ग्रेन्स को वाटर में उन्होंने ऑब्जर्व किया. द साइंटिस्ट वाज रॉबर्ट Brown. He observed, I have a glass of water, or simply if I am a chemistry teacher I would like to say it's a beaker. Okay, so this is water, H2O, and pollen grains are present. Pollen grains will be taking as circles. Okay, circles that are pollen grains. Like in the picture it is mentioned, like these circles are given here, these are pollen grains. Okay, so when they will be present, they will be poured in water, they will move zigzag. The zigzag motion will be involved, like they will move here and there like that. Okay, when you suppose you are in a rush, you will be moving here and there, something like that. He observed, he realized that it is something like we will not move here and there unless and until there is an external force, isn't it? Similarly with the case of matter particles also, these are molecules, these are also molecules, these are also particles. When they are going into tea or coffee, or suppose pollen grains will be going into water, so they are moving here and there, that means there is some external force. External force will be applied by particles only, so that is the evidence of presence of particles in matter again. Right? Brownian movement is an application, sorry, is an evidence of presence of particles in matter. Good. Fine. Now, we have seen presence of particles in matter, right? We have seen the evidences, we have seen everything, and we have learned a lot of things also, that there can be external forces present between the particles of matter. There can be some properties like dissolution present between particles of matter, right? Now, we will be moving towards characteristics of matter. Okay? We will be moving towards characteristics of matter. Now, you know, even if you are a person, chemistry is just like whatever going on in our daily life. Okay? If you are a person, you are made up of molecules, then whatever behavior you shows, molecules will show the same behavior. Okay? It's just relatable. So, whatever your characteristics, sometimes molecules also show some characteristics, and if you want to know about molecules of different matter, you also should know what are the different characteristics of matter. So, that is why we are going to learn this topic, and this topic will be comprising some activities, right. You can do the activities in your home also, you can do the activities in chemical laboratory also. So, let us see one by one all the activities. Fine. The activity 1 would be to show the particle nature of matter. Like I told you, simply we have seen evidences of particles in matter, we have already seen the evidences, but still there is an activity to show the particle nature of matter, and you know, I will tell you a surprising thing, that is the same, it is the same activity that we have done in the first evidence. Okay. See, in this picture you can observe, we have taken a beaker in which particles of water are present. Okay. Basically it is written as particles of water magnified millions of times. Yeah, of course, if we will be magnifying the molecules, then only we can see from our eyes, right. So, this is beaker, it has water molecules. Now, suppose we are adding some salt or sugar molecules. You can see some salt molecules here. When we will be adding it, it will go and settle at the bottom at first, but it has some property of dissolution in liquids. Okay, it can be dissolved in water. After some time, when we will stir it, the particles of salt, as you can see, the molecules of salt here. Okay, I hope you can see. Just wait. These are the molecules of salt. Okay, they will be going in between the molecules of water. It's the same case as similarly I have told you the same thing in evidences of matter also. So that's why the first property arises. What is the first property, or you can say first characteristic? That matter will be having particle nature plus matter will be having spaces between its particles. Okay, we will be learning that characteristics, but I will be writing it here again. Matter particles have spaces between them. Okay, let's move further. What were the observation and calculation? We have already written observation and calculation. Let's move further. Let's see activity number 2, that will be aiming to show that the constituent particles of matter are very small. Okay, like I told you, I have already told you that atom is very small. It is the building block of matter. Then atoms will be making elements, elements will be making molecules, molecules then compounds, compounds will be making matter, etc., etc. Matter will be making a lot of things. So, to show constituent particles of matter are very small, we already know, but we should have an experiment to show it to others, right? So, that's the same activity that will be telling you about constituent particles are very small. Okay. See, we have a beaker, just wait. We have a beaker that I will say as beaker number 1, and the further beakers will be called as second, third, fourth and fifth. In the first beaker, I have taken only water, okay, and I will be adding, in the second beaker, I will be adding 2-3 crystals of potassium permanganate. Here, materials required would be beakers, water and potassium permanganate. Okay. What is potassium permanganate? It has formula as KMNO4. Now, potassium permanganate has a property that it shows very deep purple color. Okay? So, if deep purple color is shown by KMNO4, it can be transferred into water also. That is why we are adding the crystals of KMNO4. Okay? See, in the first beaker there was only 100 ml of water. When we will be adding some crystals of KMNO4, this is KMNO4. Okay? We have added some crystals, level of water will not increase. Why? Because we know that particles of matter have spaces between them and matter is made up of particles, we know already. So, KMNO4 is added, 100 ml will not increase, right? Level will not increase. Now, we'll be going towards the third beaker. हमने क्या किया? We'll be taking 10 ml of liquid from second beaker and we'll be pouring it pouring the liquid into 100 ml of water in the third beaker. ठीक है. At first we had 100 ml of water in the third beaker, लेकिन उसके बाद जब हमने क्रिस्टल्स को मिक्स कर दिया वाटर में सेकेंड बीकर में, तो हमने क्या किया, इससे 10 ml निकाल के इससे विल बी टेकिंग 10 ml एंड विल बी मिक्सिंग इट विद दिस 100 ml. ठीक है. अगेन विल बी repeating the same process. We'll be taking 10 ml from this beaker and we'll be adding into this beaker to make it 100 ml of solution. Okay. Again we'll be taking 10 ml of this beaker and then we'll be adding into this beaker and we'll be making 100 ml of solution by mixing water also. What do you observe actually? We have done up to only 5 beakers, right? And we can see that color of the solution keeps on fading. At first it was deep purple color because the crystals were added only in 100 ml of water, right? As we moving further, we can see that color is fading. Why? Simply because amount of water is increasing, or you can say amount of water is almost same, but amount of crystals, or you say KMnO4 is decreasing. Why it is so? Because simply first it was mixed with water, then again it is mixed with water, then again it is mixed with water, and we can keep on mixing it with water. So amount of KMnO4 is decreasing per unit volume if you want to say, but the color is still shown. ठीक है. अगर if there is something that can still show its property even after mixing it with a lot of solvents, then we will say that it has some property, even if it is very small, it has some property. We can say the reverse also. If it is showing the property, then that means it is very small in nature. ठीक है. That's why we will say constituent particles of matter are very small. ठीक है. And one question generally students ask कि what will happen if we will be doing it infinite times. What is the meaning of, you will never get to infinite obviously, but there will be a point when the pink color will completely fade out. Okay. So when the pink color is completely fade out, it doesn't mean that crystal is not there. ठीक है. Crystal अभी भी वहाँ होगा, but you will not be able to see. So it is very small. ठीक है. You can break it down again and again and again. You can break it up to infinite. I will say there is 2 types of infinite, minus infinite and positive infinite, correct? So positive infinity is represented by space. You can go up to whatever you want, you will never reach any point. Negative infinity will be shown by atoms. You can break up to whatever you want, you will never get something, right? You will never get the end point. Okay. So that's it for the activity 2. Let's move further for further activities. Observation and conclusion we have already done in the previous slide. Let's move further. Okay. So like I said, characteristics of matter we are learning, and we just have seen some experiments. So we are just defining those characteristics now. Like I said, the particles of matter are very small. So this has been shown by activity 1. Just wait. Activity 1 have already shown that the particles of matter are very small. Sorry, not activity 1, activity 2. In activity 1, we have seen that particles of matter have spaces in between them. Okay. Let's go to the next characteristics. Particles of matter have spaces between them. So that's why when we were adding sugar particles or salt particles into water molecules, the volume of water was not increasing, right? The volume of solution was not increasing. Why? Because salt and sugar particles will be going in between the water molecules. ठीक है. So it is shown by activity 1, right. This characteristic was from activity 2, this characteristic was from activity 1. I believe you are able to understand. Now, the third characteristic and very important one is particles of matter are continuously moving, or you can say constantly moving. What is moving, or you can say they are continuously in motion. Fine. How do we know that? We have seen evidences of matter, right? In the beginning of the class we have seen some evidences. In the third evidence we have seen Brownian movement. So, in Brownian movement you have seen motion of pollen grains into water due to molecules of water. That this characteristic basically has been shown by that evidence, right. But still there are some definitions that are present in solids, liquids and gases that you have to know while learning about motion of the particles of matter, correct? Okay. So, what will be those definitions? Diffusion, osmosis. I will tell you about those both of these things, but not now. We will be learning, we will be doing some activities, and then we will be understanding what is basically happening in diffusion and osmosis. Okay. So, this is basically the characteristic. If in your exams they will be asking you different characteristics of matter, first you will be writing particles of matter are very small, then you will be writing they have spaces between them, then you will be writing they are continuously in motion, and one more characteristic, that would be the particles of matter attract each other. Okay. So, we will be doing one activity based on this also, that particles of matter will be attracting each other and they will be affecting the distance between within the molecules, right. Forces of attraction present between molecules. Right, will basically affect distance between molecules. We will be learning everything, do not worry. You will be able to understand how forces of attraction will be generated, how it will be affecting the distance between the molecules. Basically, suppose there is a lot of rush in the room. If suppose you are in a room, there is a lot of rush, then the force of attraction, or you can say the distance between two people decreases, right. That is some kind of external force. Again, if a room is very spacious, or you can say there are very less people are there, no rush. So, distance between two persons will increases. That is also according to external environment, external surroundings, correct. So, that is the same case with matter also. If suppose forces of attraction between two particles is very high, they will come together, they will try to accumulate, and that is how distance will be between them decreases. Whereas, if suppose forces of repulsion between the two molecules are higher than forces of attraction, then what will happen? Distance will be affected, distance between the molecules will increase, okay, they will be going farther. Let us move further now. Okay. Activity 3. Like I said, we will be doing activities to understand characteristics of matter, point 3 and point 4. The point 3 was particles of matter are continuously in motion. and this activity will be showing to prove, the object is, or you can say the aim is, to prove that particles of matter are in a state of continuous motion. ठीक है? See what this diagram is showing you. This is the first beaker, right? This is the second beaker. Okay. What is happening? Suppose this blue part is showing water. This red part is showing any particles. If you want to add coffee, okay, suppose you love coffee, coffee particles, or coffee is a kind of solid, okay, we will be taking some gas. It would be better if we will be taking gas. So, I will be adding oxygen molecules. Okay. Suppose I have added oxygen molecules in the beaker containing water. ठीक है? What will happen at first? It will be first at the instant it will be accumulated. ठीक है? After some time I will see that the oxygen molecules have just spreaded, completely spreaded in the water. That's not only in the case of water. If suppose I have two empty beakers, not the beaker, one empty container, or I can say one empty room in which I am standing. Suppose the air conditioner that is in my room will start giving out carbon dioxide, but I will die because of carbon dioxide, so I will not be saying that. I will say it will be giving oxygen molecules. ठीक है? So, when oxygen molecules will be coming out of air conditioner, at first they are accumulated together, right? But after some time what will happen? After some time all the oxygen molecules will be spreaded all together in the room, means everywhere in the room. That seems to say that molecules of oxygen are continuously in motion. That is why they are able to reach every corner of the room. Okay. So, that is the activity, that is basically the experiment to show they are continuously in motion. Like I said, like I told you, that when we are learning continuous motion of particles of matter, we are supposed to encounter some definitions, है ना? Okay, this is building concept. Let me tell you some definitions. One basic definitions will be, first of all we'll be learning particles of gases, okay. Motion of gas particles. Okay. So, suppose like I said, very basic example, or I can tell you another example. Suppose I think your favorite food might be Maggi or pizza or burger, isn't it? You are supposed to eat it less, but still, suppose your favorite food is Maggi, and you are in a big room. There is a very big room, and Maggi is cooked at some corner of the room. Okay. So, how will you understand? How will you realize that Maggi has been cooked and I am supposed to go there and eat it? You will get smell, correct? Of course, you will get smell. If you are having some doubts, you can go into your kitchen and ask your mother to make Maggi. Okay, she will be making, you will be getting the smell. So, why the smell is reaching to your nose? How the smell is reaching up to your nose? That is because the molecules of smell, right? The molecules that will be carrying the smell of Maggi will be reaching to you. How? Because they are continuously in motion. They are moving randomly here and there. They will be reaching from the position at which there are a lot of molecules having that smell to the position at which there are very few molecules that are having that smell. Means, if I have this room, these molecules that have smell of Maggi is very high number at this corner, but very low in number at these corner, these corner, these corner. So they will be moving here, moving there, here, moving here. Okay, this is called as high concentration. High concentration. High concentration of what? Molecules. Concentration means if something is high in number, we can say high concentration. And at these corners there will be low concentration. So means when your mother is cooking Maggi, the surroundings around your mother is having high concentration of the smell of Maggi, but the surroundings around you is having low concentration of smell of Maggi. So movement of gaseous particles from high concentration of particles to low concentration will be called as motion, and it will be called as diffusion. So you will be saying movement of particles from high concentration of particles to low concentration of particles. That is the definition of diffusion in gases. Okay? I believe it's clear. Now let's move forward towards the motion in in liquids. Just wait. Motion in liquids. So there will be two types of motion in liquid. First, see, always moving of particles will be from high concentration to low concentration only, right? But there can be different types of particles, right? In liquid there are two types of particles. Basically liquid, we will be studying liquid solutions. So liquid solution is basically will have solute plus solvent. Solute and solvent are the two components of a solution. Okay? Solute is something that will be added. Solvent is something that will already be present in the beaker. Suppose we have in the beaker we have water, we are adding any liquid. Any liquid you can take juice, or you can take lemon juice, yeah, whatever you want, ink, right? So solute will be called as solute will be that ink or lemon juice, and solvent will be water. Okay. So now there are two types of particles that will be present in liquid: solute particles and solvent particles. These will be having fine. Solute will be having solute particles, solvent will be having solvent particles. in motion in liquids, first definition would be for diffusion again. If we have a beaker, we have H2O and we are adding, suppose we are adding ink, we can take ink, pink ink, okay. I have added pink ink. So, at first this ink will be accumulated like this, right. At first it will be together, all the molecules of ink will be together, but after some time it will be going further in the water and it will try to make the water colorful. So, this is called as diffusion of liquid in a liquid, okay, in which motion of liquid particles will happen from high concentration of solute particles to low concentration of solute particles. Let me write it. Sorry, one second. This is motion from high concentration of solute particles to low concentration of solute particles. Done? Always remember this is what we called as diffusion. For gases and liquids, same definition. Second definition that you have to understand is osmosis. See, osmosis is the movement of solvent particles from higher concentration of solvent to the lower concentration of solvent. Like I said, there will be two types of particles, solute particles and solvent particles. Here, motion of solvent particles from high concentration, it says high concentration to low concentration. You can refer high concentration and low concentration from the first definition. Okay. Let me just make the diagram of osmosis and it will be okay, it will be done. So, suppose we have two reservoirs or you can say two containers connected with each other. And they are having a membrane or you can say a layer of something separating them. This is the first reservoir, this is the second one, this is SPM, membrane. What is SPM? SPM is semi-permeable membrane. So, semi-permeable membrane is a membrane which will be having permeability to some particles only. Solvent particles are actually small in nature, small in you can say size, and solute particles are actually larger. So, that is why only solvent particles can move from SPM, that is semi-permeable membrane. Synthetically, if artificially we will see, then cellulose can be taken as semi-permeable membrane. And in our body, there are a lot of semi-permeable membranes present between our tissues and blood cells. Okay. So, suppose in one first reservoir, there is only solvent particles, that is water, H2O only. And in the second reservoir, there will be presence of solution, any solution, because solution will be having solute and solvent also. Okay. So, osmosis is basically movement of solvent particles from higher concentration of solvent particles to lower concentration of solvent particles. That is why movement will be happening like this from first to 2, right. I think you can see the arrow, it will be moving, the solvent particles will move from first reservoir to the next reservoir, and that will be the movement of particles from higher concentration to low concentration. Okay. So, we have seen a lot of definition in motion of particles in matter. I will be just telling you about solids. In solids generally diffusion will happen, but it will be happening very slow. So, it is the same definition in solids also. Simply if we have taken again in a beaker we have taken water and again we are adding sugar. Okay. So, sugar will be dissolved, but at a small rate, है ना. Liquid will be dissolved very fast because it can flow easily. Sugar will also dissolve, but at a small rate, smaller than liquid and gases. So, diffusion in solids will be very, very small. One thing I would like to write here is diffusion is also can be considered as intermixing of gases or liquids, gases and liquids or liquids and liquids or solids and liquids, like that. Okay, fine. So, our third characteristics is completed, that particles of matter are in continuous motion. And let us do an activity, or you can say let us build our concepts. Okay. But this is actually the same kind of example that I have given you. Basically, if suppose you are in a room, है ना, and someone is applying perfume. So, we can still smell that perfume even if we are meters away. Now, it is your work to tell me what is the process or what is the phenomenon behind it. Okay. So, I hope you can tell me, just write in the comments and I will be checking it. Fine. Let us move further. Okay. Let us go towards activity 4. What is the aim or object of the activity? To demonstrate that the kinetic energy of particles increases with increase in temperature. Okay. So, you know what is, first of all, before doing this activity, you should know what is energy and what we call it, what is basically kinetic energy. So, you know, energy is actually the ability to do work, correct. If you have greater energy, you will be working in a greater manner, okay, better than anyone. Energies can be of different types. Most basic different types of energy are kinetic energy, and potential energy, right. Now, what is kinetic energy and potential energy? You will be definitely learning about them in physics, but suppose potential energy is, let me tell you, potential energy is the energy that is related to your position, okay. Whether you are at some height, whether you are at some slant, okay, wherever you are present, at which position, potential energy will be that energy at that position, okay. What is kinetic energy? Kinetic energy, because we are going to learn about it, let me tell you, can be represented by Ke. इट इज़ द एनर्जी ऑफ द पार्टिकल्स दैट आर कंटिन्यूसली इन मोशन, ठीक है. सो इफ यू आर ऑल्सो मूविंग यू विल ऑल्सो पोजेस काइनेटिक एनर्जी, है ना. एनी ऑब्जेक्ट्स, मैटर में पार्टिकल्स होते हैं, हमने देखा था एटम्स, मॉलिक्यूल्स, कंपाउंड्स मूव करते रहते हैं, दे आर कंटिन्यूसली इन मोशन. वी हैव सीन डिफ्यूजन, ऑस्मोसिस, राइट. सो उनके पास क्या होगी, काइनेटिक एनर्जी होगी, राइट. एंड हाउ काइनेटिक एनर्जी इज अफेक्टेड बाय टेम्परेचर इज द एम ऑफ द नेक्स्ट एक्टिविटी. सो let's do it. फाइन. सी एम क्या है, काइनेटिक एनर्जी का, काइनेटिक एनर्जी पे टेम्परेचर का इफेक्ट देखेंगे. मटेरियल्स क्या क्या लगेंगे इसमें. सी बीकर, यू कैन टेक बाउल्स और ग्लासेस, है ना. वाटर, हॉट या कोल्ड, मतलब 2 बीकर लेंगे बेसिकली. देयर विल बी 2 बीकर्स. ए वाले में कोल्ड वाटर रहेगा, बी वाले में हॉट वाटर ले लेंगे, ठीक है. अब हमने क्या किया, पोटेशियम परमंगनेट क्रिस्टल्स लिए. देखो पोटेशियम परमंगनेट क्रिस्टल्स क्यों ले रहे हैं, क्योंकि वी विल बी एबल टू आइडेंटिफाई कलर कितनी जल्दी हमारे पूरे लिक्विड में स्प्रेड हो रहा है ना. जितनी जल्दी कलर हमारे लिक्विड में स्प्रेड होगा उतनी ही जल्दी हम समझ पाएंगे कि पार्टिकल्स ऑफ मोशन आर पार्टिकल्स ऑफ मैटर आर हैविंग सम स्पीड, है ना. जितनी जल्दी होगा उतनी ज़्यादा स्पीड है, जितनी देर में होगा उतनी कम स्पीड है, राइट. सिंस पोटेशियम परमंगनेट आर क्रिस्टल्स, सो क्रिस्टल्स जनरली सॉलिड होते हैं. आई टोल्ड यू, आई थिंक दैट सॉलिड्स का डिफ्यूजन बहुत ही कम होता है ना. बिकॉज गैसेस, we'll be learning about gases and liquids, don't worry, we'll be learning about every physical state of matter, but just focus on what I'm telling you right now. Liquids and gases can easily flow, but जो solids होते हैं वो easily flow नहीं कर सकते. That's why solids का जो movement और you can say diffusion होता है वो बहुत less होता है, right. So हमने cold water लिया, हमने hot water लिया, इसमें हम क्या करेंगे, पोटेशियम परमंगनेट के क्रिस्टल्स डालेंगे. यू विल सी, यू विल ऑब्जर्व, just wait, okay, you will see what will be the observation. That in hot water mixing of crystals in water happens very fast. Okay, mixing of crystals in water happens very fast. How will we know that? जैसे ही हम लोग क्रिस्टल्स डालेंगे तुरंत ही उसका पूरे वाटर का कलर पिंक हो जाएगा. ओके, this cannot be considered as observation, this can be considered as conclusion. Right? Another conclusion will be in cold water mixing of crystals happens slowly. है ना? Why it is so? See, कोल्ड वाटर है, हमने देखा कि हमने जैसे क्रिस्टल्स डाले, देखेंगे कि जो कलर स्प्रेड हो रहा है वाटर में वो बहुत धीमे धीमे होगा. तो why it is happening? Suppose molecules are just like human beings. तो अगर हम एक कमरे में हैं, काफ़ी सारे ह्यूमंस एक कमरे में हैं, एंड सपोज समवन इज़ इंक्रीजिंग टेम्परेचर, है ना, हमारे ऊपर एक्सपेरिमेंट हो रहा है अब. तो जो टेम्परेचर इंक्रीज करेगा उसकी वजह से लोग इधर उधर भागना स्टार्ट करेंगे क्योंकि दे वांट टू गेट आउट ऑफ दैट रूम, है ना. सिमिलर इज द केस विद मॉलिक्यूल्स ऑल्सो. इफ दे आर इन अ कंटेनर, we will be increasing temperature, they will try to move here and there, random motion will happen, है ना. So generally when random motion happens, speed also increases because they will be colliding with each other. Definitely they will just after collision speed increases like that. Okay, random direction में random motion होगा. That's why in hot water at high temperature हम कह सकते हैं कि crystals बहुत जल्दी mix हो जा रहे हैं, पर कोल्ड वाटर में ऐसा नहीं हो रहा. सो दैट इज़ द एक्टिविटी दैट इज़ टेलिंग यू अबाउट द इफेक्ट ऑफ टेम्परेचर ऑन काइनेटिक एनर्जी ऑफ पार्टिकल्स, है ना. लेट्स मूव फर्दर, लेट्स डू सम अदर एक्टिविटी. ओके, वी हैव डन activities based on motion of particles, है ना. We have seen different definitions like diffusion, osmosis. We have done activities. We know now about kinetic energy, but we haven't done much activities on this forces of attraction. Like I told you a statement basically कि particles of matter will be attracting each other, है ना. They will be having some forces of attraction. In some matter it will be less, in some matters it will be more. So what is there in activity 6? What is basically we are going to do to demonstrate the strength of attractive forces between particles of different kinds of matter. ठीक है, 1 second. Okay, fine. So basically in this activity you are supposed to take different objects, right. Suppose I have taken liquid, any liquid, suppose water, simple. I will be taking any solid, suppose wood, है ना. तो क्या होगा कि if suppose I want to apply some external force on water, if I will try to cut it, if I will try to hammer it, क्या water में कोई change आएगा, क्या water breakdown हो सकता है, या करेक्ट, ब्रेकडाउन नहीं हो सकता, ऐसा कोई चेंज, वाटर कैन नॉट बी कटेड डाउन, है ना. देखो, दिस इज ट्राइंग टू टेल यू समथिंग अबाउट नेचर और द वे मॉलिक्यूल्स आर प्रेजेंट इन वाटर, है ना. सॉलिड में बात करें तो अगर उसको हैमर करेंगे, वुड को हैमर करोगे, इट विल बी ब्रेक डाउन. कट करोगे, कट हो जाएगा. दिस इज ऑल्सो ट्राइंग टू टेल यू समथिंग अबाउट द नेचर ऑफ द सॉलिड. तो what it's trying to tell you, basically there will be particles in it. ठीक है, हम जो आगे पढ़ेंगे, हम जब फ्यूचर अपकमिंग स्लाइड्स में पढ़ेंगे तो देखेंगे कि जो सॉलिड्स होते हैं उसमें इंटरमॉलिकुलर फोर्सेस जो होती हैं उनके मॉलिक्यूल्स में बीच में वो बहुत ज़्यादा होती है ना. और जो लिक्विड्स होती हैं उनमें इंटरमॉलिकुलर फोर्सेस थोड़ी कम होती हैं. तो लिक्विड्स के मॉलिक्यूल्स थोड़ा दूर दूर रहते हैं, सॉलिड्स के मॉलिक्यूल्स दे स्टे टुगेदर, they stay in touch. So when we are trying to cut them, cut solids, है ना, they are actually already rigid. ठीक है, surface का the knife and the surface of the solid can be touched together. They will be, it will be having some effect. But there is basically almost negligible surface in liquid, है ना. कोई surface नहीं होता, कोई rigid surface नहीं है. तो हमारे जो नाइफ है और जो सरफेस है लिक्विड का, देयर विल बी नो काइंड ऑफ वेरी नेग्लिजिबल टच बिटवीन देम. कट नहीं हो सकता, कोई मॉलिक्यूल कट नहीं होगा, ठीक है, कोई सरफेस कट नहीं हो सकती बिकॉज इट इज़ नॉट रिजिड. सो इट इज़ एक्चुअली ट्राइंग टू टेल यू डिफरेंट फोर्सेस ऑफ अट्रैक्शन एंड अकॉर्डिंगली डिफरेंट intermolecular distance will be present between solids, liquids and of course in gases also, right, because these are different types of matter. Fine. So this was the activity that was demonstrating the strength of attractive forces. We will be learning more about intermolecular forces of attraction. Okay. So we have seen activity number 6, that is actually demonstrating different matters and their different molecular force of attractions, right? Let's go towards building our concept. So, let us build our concept. See, we can easily move our hand in the air, but to do the same through a solid block of wood, we need a karate expert. Why? So, do not ever try this at your home. If you are trying to break down a wood, okay, a piece of wood, you will need a karate expert. You are not that expert right now. So, why it is so basically? ठीक है, like we have already demonstrated or we have already seen in the previous activity कि कुछ there are some matter, है ना, there are some types of matter in which molecules will stay together, they will be making the matter rigid. Rigid means hard, है ना. Let me write it. Some matter are rigid, not have, we will say are rigid. Some matter are you can say soft or discontinuous, or you can say have spaces between molecules. Right. So, basically rigid, okay. Rigid means hard. So, basically if a metal, not a metal, if a matter is hard, if you will just try to hit it, you will be injuring your own hand. But if suppose there are spaces between molecules, right, molecules are also present in the air that you are breathing, okay. Like I can move my hand like this here and like that, okay. So, it is actually why I can move it, why? Simply because there are spaces between the molecules present, है ना. Spaces present होंगे तो my hand can adjust the different molecules. लेकिन अगर spaces है ही नहीं, surface जो है वो rigid है, hard है, तो मेरे जो हाथ के जो compound है, obviously my hand is also made up of chemical compounds, right? They are also rigid because it is solid, है ना. कोई भी solid substance होगा, if my when I will be hitting it, I will be feeling the injury, okay. So, that is basically simply the concept behind intermolecular forces between particles of matter, right. So, we have seen these building concepts and now we know very well how we can how matter particles of matter have spaces between them, ठीक है. So, आज की क्लास में हमने देखा what is matter, then broadly हमने matter को classify किया in physical classification and chemical classification. Chemical classification we are not learning in this chapter, we are learning only physical classification. So, basically we have seen characteristics of matter, ठीक है. सारी characteristics देखी, उनके evidences देखे. Now, in the next class we will be learning about classification of matter and their physical states, classification according to the physical classification and it would be physical states, that would be solids, liquids and gases. So, we will be meeting in the next class, okay.